Okay, this video is about testing the difference between two means with independent samples and unknown population standard deviations. Marla is studying the sodium content of cold cuts. A random sample of 852-gram samples of smoked beef. So we have a sample of 8 samples of smoked beef. They had a sample mean of 15.55 grams of sodium. With a sample standard deviation of 0.50 grams. Another independent random sample of 652 grams samples of smoked turkey produce a sample mean of 1250 grams with a sample standard deviation of 0.75 grams. Test to see if there is a difference in the mean sodium content of the above brands of smoked beef and turkey. Use alpha equal 5% level of significance. Let me just write this here of significance. It should be significance here. Assume population variances are not equal. As we work out the solution, I'll tell you where we use the final statement that the population variances are not equal. We're going to assume here the populations are normally distributed because the sample sizes are less than 30. The conditions of the test, guys, that the population must be normally distributed. So we made this assumption. The samples are random. As you read through, it says the samples are random and they are independent. The samples are independent as well. First of all, we're going to state the null and the alternative hypotheses. We're going to assume that mu1 stands for the mean sodium content of smoked beef, and mean 2 refers to the mean sodium content in smoked turkey. And we need to test that mu1 is different from mu2 because he says test to see if there is a difference in the mean sodium content of the two brands. The null hypothesis is a statement of equality, so it's going to be mu1 equals mu2. What we are going to run, we're going to run t-stats using StatCrunch with two samples. And then we'll go to StatCrunch and I'll walk you through the solution. So there's a StatCrunch, you click on Stat, t-stats, two sample with summary. I don't have the actual data, so it's with summary. All right, let's reduce this a little bit in size so you can see the whole thing right here. All right, okay. Sample mean, we have 15.55 for smoked beef. Sample standard deviation, I have 0.50. Sample size, how many? We had 8 of those. Sample 2, the sample mean is 12.5. The sample standard deviation is 0.75. And the sample size was 6. Okay, let's continue. Okay, since he says assume population variances are not equal, we would not check this one, the pooled variance. We only check it when he says assume population variances are equal. So if it is unchecked, that means we are assuming population variances are not equal, and this is what the question says. By default, it's always not checked. Now we come here. We need to test that mu1 is different from mu2. And testing that mu1 is different from mu2 is the same thing as testing mu1 minus mu2 is different from 0. So don't touch the 0 here, just leave it alone. So this is exactly what we need to do. If you guys want to see the p-value in action, you can do a plot right here. And if you want the critical value, it will give you the critical value, and make sure to put the right significance level, which is 5% here. I'm going to hit compute, and let me just bring this inside the recording window so you can see it. All right, there you go. We need to show a little bit more. All right. So the test statistic is 8.627 with 3 decimal places. So 8.627. And the p-value is so small that it says less than 0.001. When the p-value low, HO must go. If the p-value is less than alpha, you must reject the null hypothesis. So let's go back to our question and show the remaining steps of the solution. If you want to see the p-value, you're not going to be able to see it. It should be on both sides of the curve, but because it's so small, guys, you're not going to see much of it. Look, it is on the right-hand side and left-hand side, right here and right here, and you barely see anything because the p-value is so small. So step number 1 is state the null in the alternative hypothesis, which we already stated that one. The test statistic is step number 2, which is 8.627. P-value is less than 0.0001, which is less than alpha. So we reject the null hypothesis. And if you guys reject the null hypothesis and the claim is in the alternative hypothesis, you support the claim. And you say there is enough evidence at the 0.05 level of significance to support the claim that there is, I'm just copying and pasting here, there is a difference in the mean sodium content of the above brands of smoked beef and turkey. That concludes this exercise.